Good afternoon, children. This is Hanuman sir here. In the previous class, we were discussing about statistics, right? So today I am going to take you on the new topic, that is triangles. Under triangles, we have 5 theorems are there. In that, so one of the most important theorem is Pythagoras theorem. So Pythagoras theorem, it carries 5 marks for your SA1 and SA2. So please follow the steps and understand the theorem, and you have to do hard work for this. Okay children, let me start the theorem. So state and prove that Pythagoras theorem, right? So I will repeat once again the question is state and prove that Pythagoras theorem. So the statement Pythagoras theorem states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. I'll repeat the theorem once again. In a right angle triangle, according to Pythagoras theorem states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides, right? So next step, we have a diagram. So see here, ABC, triangle ABC is a right angle triangle. Triangle ABC is a right angle triangle. So the angle B equals 90 degree. It shows that the angle ABC is 90 degree, right? So the next step is data. So the given data is in a right angle triangle ABC, in a right angle triangle ABC, so angle ABC, which is equals to 90 degree, right? So we need to prove that see, AC square is equals to AB square plus BC square, right? So AC square, which is equals to AB square plus BC square, that is only the statement in a right angle triangle. Here we have a right angle triangle ABC, right? The square on the hypotenuse. So we know that the longest side of a right angle triangle is called a hypotenuse. So here we have the longest side of a given triangle ABC is AC. So AC is the longest side, so AC is also known as hypotenuse. According to Pythagoras theorem, in a right angle triangle, the square on the hypotenuse, so the square on the hypotenuse, here we have the hypotenuse is AC. So the square on the hypotenuse AC square, which is equals to the sum of, see, sum it is a plus, so sum of the other two sides, sum of the squares on other two sides, right? So this is the sum squares on the other two sides. So these are the squares. So the squares on the other two sides, that is AB and BC, right? So according to statement, we need to prove that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So here we have AC be the hypotenuse and AB and BC are the other two sides. According to the statement, we need to prove that so AC square, that is hypotenuse, sum of the other two sides, that is AB and BC. So we need to prove that AC square is equals to AB square plus BC square, right? So next we have to do the construction. Here we have draw a BD perpendicular to AC, right? So draw BD perpendicular to AC. So we can draw a line segment BD is perpendicular to AC. So we can draw a BD perpendicular to AC. That is construction. Next we have proof. Under proof we have statement and reasons. So the given statement is in right angle triangle ABC. So this is whole triangle ABC and right angle triangle ADB. So this is a ADB. ADB, right? So here we have understatement, we have two triangles, one is ABC and another right angle triangle, it is ADB, right? So given two triangles, here see it can represent by observe, it can it is clearly seen that see AB is corresponding to AD and AC is corresponding to AB. So we can compare the sides of these given two triangles. So angle A, which is equals to angle A, are the common angles. That is the reason, right? So angle A equals angle A. So angle A of given two triangles, the given angle A is common angle to both, right? Next we have angle B, which is equals to angle D, right? So that is angle ABC is which is equals to angle ADB, because data under construction, so the given two triangles are congruent, so this is a symbol for congruent. So congruent triangles means any two sides and one angle of one triangle are equal to corresponding angles and corresponding two sides of other triangle, then are equal, then they are called congruent triangles. If two triangles are said to be congruent if their corresponding angles and corresponding sides are equal, then the given triangles are congruent. So here we have angle A, which is equals to angle A. It is a common angle, so both the angles are equal of two triangles. Okay, then angle ABC and angle ADB, which is equals to, this is 90 degree children, this is 90 degree. So because data under construction, hence the given two triangles are congruent. So the given triangles, triangle ABC is corresponding to triangle ADB by angle similarity criteria. Angle similarity criteria states that all the angles of one triangle are equal to corresponding angles of other triangle, then it is a angle similarity criteria, right? So it can be observed that the corresponding sides AB by AB is corresponding to the side AD, so we can write AB by AD, which is equals to the corresponding side of AC is here AB. I will repeat once again. It is clearly seen that AB is corresponding to AD and AC is corresponding to AB. By representation only it is clarified to all, right? So AB is corresponding to AD and AC is corresponding to the side of AB, right? So given triangle C AB by AD, which is equals to AC by AB. By doing cross multiplication, we get C AB into AB. So by doing cross multiplication of these, so AB into AB, it is AB square, and AD into AC, it is AC into AD. Right? AB into AB, AB square, and AD into AC, it is AD into AC. Okay, children?